Hello, everyone. Good afternoon. I welcome you all. We are glad you are here for our webinar on the topic of 4 steps to sustainable maintenance cost reduction. My name is Sashma Best, and I'm a support officer for ASCI. Today's webinar will focus on lower maintenance cost in a sustainable way, as maintenance costs heavily influence operating expenses in asset-intensive industries. Our expert speaker, Eric, is here to help you understand it well. Eric is the founder of Reliability Academy, and he has over 25 years of experience in managing maintenance and reliability. During those years, he worked for multinational companies in the energy sector in the Netherlands, UK, Philippines, Oman, and Australia. Eric is a certified maintenance and reliability practitioner, certified reliability leader, certified asset management assessor, a chartered professional engineer, and holds an executive MBA and a master degree in systems engineering. But these are just credentials. It is Eric's industry experience and practical approach to the topics he teaches that his students and clients appreciate. Eric's passion is for continuous improvement and keeping things simple. Through the Reliability Academy, he helps maintenance and reliability professionals around the globe, improving their plants' reliability and their organizational's bottom line. This is an opportunity to learn from this session. Please ask questions and share your own experiences. Before we begin, let's review a few house rules to ensure everyone has a positive and productive experience. If you have any questions or comments, please use the Q&A box at the bottom of your Zoom window. Also, please be aware that this webinar is being recorded and it will be uploaded to our YouTube channel after the webinar. We appreciate your cooperation and hope you enjoy the webinar. Thank you so much for joining us today. Now I will hand it over to Eric to start. Thank you so much, Eric, for giving your time today. Over to you now.
Thank you, Shashmi. All right, everyone, welcome to this webinar. As mentioned, my name is Eric Capier, and in the next 30-40 minutes or so, I'm going to walk you through a high-level presentation on the 4 steps to reduce your maintenance costs in a sustainable manner. Now, to be clear, everything I'm going to be sharing in this webinar isn't particularly groundbreaking or really new, to be honest. What I'm going to be doing instead is giving you a very simple framework that I've used myself in the past. I've worked with clients on it, and I know that it works. Now, before we delve into a lot of detail, let me share a little bit more about myself. Shashmi already gave a summary, so I won't share too much. But my background is, I grew up in the Netherlands, first of all, let me mention that, which explains the accent. So I've worked for 20 plus years or so for multinationals like Shell and ConocoPhillips across the world, managed lots of different assets, old assets, new assets, billion-dollar greenfield projects, onshore, offshore, oil, gas, unconventionals, LNG plants, etc. I've managed small maintenance teams with literally tiny budgets to relatively large teams with very substantial maintenance budgets, over $100 million a year. I started what is now called Reliability Academy back in 2018, primarily out of a frustration with what the industry offers as solutions. Because as a customer, what I found was that so many of the solutions that are out there are overly complex and often actually ignore the fundamental basics of good maintenance and good reliability practices. And typically, I found that not enough attention was paid to kind of building capability in an organization around reliability and around maintenance. And in my view, that's kind of where it all starts. And so what I do now through Reliability Academy is I help clients around the world train their teams in maintenance, in reliability, and in some of the common practices or basic practices that we're going to talk about today. So let's get on topic, maintenance costs. Look, no matter where you are in the world, maintenance costs are under pressure. In fact, to be honest, they're always under pressure, right? For most assets-intensive industries, whether it's large-scale manufacturing, power generation, oil and gas, mining, chemicals, for all those industries, maintenance costs are a very big part of the total operating costs. They're typically somewhere between 20 to 40% of the total operating costs. And in some industries, like in mining, for example, that percentage can actually go as high as 50%. So we're talking really big numbers, many, many millions. In some companies, global companies, it will be billions. And so when things get tough in industry, when the economy takes a turn for the worst and costs have to be reduced, budgets are going to get slashed. And guess whose budget is on the chopping block first? Well, that's typically the maintenance managers. I've been there, and maybe some of you have been there too. And look, there's little we can do about the business environment we're in or the need to cut costs or at least reduce costs. But the thing is, what we can do something about is how we cut those costs. I mean, we've all seen the classic approach. You know, you just simply slice, chop 10, 20, 30% of the budget. You defer all that work. You send people home. Job done, right? 10, 20, 30% of the budget. And look, a lot of industrial plants can actually limp along for 2 or 3 years before that lack of maintenance really starts to haunt the organization. And by then, in reality, very often it's the next maintenance manager who then has to deal with the consequences. Chances are we've all seen that happen throughout our careers more than once or twice. So my request is that we actually don't do that this time round, that we actually adopt a more structured, more disciplined, and a more sustainable approach to reducing maintenance costs. And that's exactly what I'll be sharing with you today. And look, what I'm sharing with you today is a framework, something that you need to adopt for your business. You need to adapt it to how it works for you, but it is a simple framework and it is effective. Now, before I delve into a bit more detail, I want to make one thing really, really clear, and this is basically the fundamental on which all this is built, is maintenance costs are a consequence. They are the consequence of the amount of preventive maintenance we do. They're the consequence of the amount of equipment failures we experience. They're the consequence of the amount of people we have working for us, whether it's employees or contractors, and they're a consequence of how efficient we are in executing the work that we do. And they are a consequence of what we pay for the services, the materials and parts we buy. And so maintenance costs are a consequence of how we set up and how we run our maintenance. Now, when you think about it, when it comes to how you spend your maintenance budget, in basic terms, you spend your money on 3 things. On labor, whether that be your own employees or contractors. You spend a big chunk of your budget on parts and materials and consumables and tools. And then likely, depending on the industry and how much you outsource, you could be spending a lot of money on external services, whether that is specialist contractors or OEM services. So if you want to bring down your maintenance costs, what you need to do is actually pretty straightforward, right? You need to do less work. You need to be more productive. You need to use less materials and you need to purchase less services. It's quite easy, really. So the what is obvious. The problem is, how do we do that? How do we do that in a sustainable way? How do we get to the point that we do less work, we use less parts and materials, we call off less external services, we pay less for what we buy, and we still achieve a good maintenance performance and have high or acceptable reliability? Now, chances
Eric,
are
can you give me a minute?
yes, sure.
There is a participant, Subhash Chandra. He has raised his hand. Subhash, I wanted to let you know, please use Q&A box if you have any questions, and all the questions will be answered at the end of the presentation. Thank you. You can continue, Eric, now.
Yeah, no worries. I did see something come up through the screen. Apologies, Subhash. I'm not very used to Zoom. All right. So chances are you might be sitting there and think, okay, yeah, that's all very nice, Eric, but that's just basically impossible. And, I can understand that you might feel that way. But the thing is, if you look around any major industrial plant, whether that's here in Australia or overseas, whether it's in mining, oil and gas, chemicals, or a power gen plant, if you look carefully at what maintenance is done and then how that work is done, you will very quickly, and I mean very quickly, see huge amount of waste. And interestingly enough, that waste is almost always in the same areas. And so when it comes to reducing maintenance costs in a sustainable way, there are typically four things that you need to tackle to eliminate that waste, which is what I'm showing here in this chart. These are the four things that you need to focus on if you want to reduce your maintenance costs in a way that they will stay down and without damaging your business. First of all, you need to address your preventive maintenance program. Those are all your preventive maintenance tasks you do on a yearly basis, right? In most industrial assets, the PM program has not been optimized. Typically, it's been copied from OEM manuals. It's been added on through a whole bunch of audits and lots of other things. The result is we have PM programs that are very wasteful with a lot of tasks that don't really add value, a lot of tasks that are done way too often. And we have a lot of tasks that actually aim to prevent failure modes that don't really matter, or tasks that are so poorly defined that they're not done properly. And at the same time, we also often find that there's tasks missing, tasks that actually could be preventing some of the main recurring breakdowns we're experiencing. Now, industry literature, my own experience and experience from lots of other people in industry shows that over and over again that these PM programs that are unoptimized typically have about 40 to 60% of their PMs not adding value. And so those tasks basically are wasting your scarce resources, right? And they're inflating your maintenance budget, but not really giving you any return on your investment. They're basically a waste of your money. So if your PM program has not really been reviewed in recent years, which is the case for almost all industrial assets, I would say from my experience, you typically can reduce your workload by at least 20%, maybe more. And so what you do, if you optimize that, you're taking away 20% of the work. And depending on how you're structured, you can immediately reduce costs. If all your work is executed by internal labor, my recommendation would be you then don't get rid of 20% of your people, but you take that capacity and start tackling the next topics. But typically you find that a lot of organizations actually bring in a lot of external contract labor to deal with all that work they have, because most maintenance organizations struggle with the workload they have. So removing 20% can typically lead very quickly to a significant reduction in the external labor you bring in. And that is an immediate cost saving. But it's a cost saving that is sustainable and is actually not going to undermine the integrity and reliability of your asset. The second area you need to look at is low maintenance productivity. At most industrial sites, the average day of a technician is just full of waste. And if you were to do a study, you typically see that maintenance productivity is somewhere between 20 to 30%, right? Which means that out of say a 10-hour day for a technician, they're only getting about 2 or 3 hours of real maintenance time done. The rest of the time is wasted, not because they're lazy, not because they're not working hard. It's because the processes we have set up are inefficient. And so there's poor communication, poor coordination, and technicians spend a lot of their time looking for parts or tools, waiting for permits, waiting for isolations to put in place, waiting for instructions for supervisors because something has changed in the field, waiting for equipment to become available because operations hasn't actually isolated the equipment or made it available to work on. All those reasons happen over and over again every single day. And so at the end of the day, technicians actually do very little productive maintenance cost of maintenance work, right? And this is typically because there either isn't a structured planning and scheduling process in place, or it is not really effective. Now, a typical plant runs with a maintenance productivity of around 30%. With effective planning and scheduling, you can increase that to about 45%. That is very achievable. It is not a world-class performance. It's not too hard to do. And that translates to a productivity increase of 35%. And so you get 35% more work done without hiring any more people. And that's without having to bring in external planners and schedulers to do this. You basically retrain some of your people to do this, right? So you can get a 35% increase in productivity in most industrial assets within 6 to 12 months by doing this. And again, that means you can get more work done with less people or with the same people. The third area you want to tackle is the number of equipment failures that you're experiencing. If you walk into the average industrial plant, you find that maintenance teams are doing the same repairs again and again and again, right? And so what tends to happen in organizations if they have a significant failure that has happened and it's happened again, what happens is that organizations actually start becoming really good at fixing that failure, right? So the culture shifts from forever fixing the same failure rather than fixing that failure forever. So they're continuously fixing the same thing and they're getting really good at that. They're setting up extra spares, they're setting up special procedures, they have dedicated procedures for that. They may have dedicated people to do the task. So if that breakdown happens again, they can fix it really fast. But what we want to be doing, what we need to be doing actually is eliminating those repeat failures, because breakdown maintenance is expensive, it's time consuming, and it actually drives most maintenance organizations into a reactive maintenance culture. And typically you find that there's probably about 5 to 10 pieces of equipment or systems that account for the vast majority of breakdowns in an industrial asset. So when you tackle those through a combination of root cause analysis and defect elimination, you can eliminate those bad actors basically, and you can reduce your corrective maintenance cost by at least 20%, if not more, right? So that is a significant cost saving on its own. Now, the last lever to tackle are your maintenance contracts. And there is a whole range of things to look at there. But when you look at maintenance contracts, and I'm talking especially about kind of larger scale contracts, you typically find that the operating company has required the service provider to deliver to standards that are actually higher than what is needed. Where we might be asking for certain specifications, certain response times, certain kind of assurances, insurance, etc., that actually, if we were critical, we don't truly need. What most operating companies don't understand is that a lot of that over specification that we push onto service providers drives costs quite significantly. The second thing is, if you look at how these contracts are often structured, they are usually not incentivized. And if they are incentivized, the goals are misaligned. I've seen so many times that maintenance contracts have been incentivized, or so they say they've been incentivized by certain KPIs. And yeah, the contracts deliver on those KPIs, but actually the KPIs are a very, very narrow view of the world and actually don't really align with the bigger objective of the organization. And so you're not actually really getting good value for money. Now, with all those things, what you can do is basically, actually what you need to do is you need to work with your contractors and your service providers to understand what is driving their cost and what you really need and what you don't really need. Too many times, this is a one-street communication from the operating companies to the contractors and say, right, we need this, you supply us that, and that's what we get. But if you have an actual conversation with your contractors about what drives their cost and how costs could be reduced and what kind of risk you might be willing to take on, you can significantly reduce costs. There's not going to be as much as in the earlier elements, but there's definitely a significant opportunity there. And that's the other thing that I just touched on there. You see a lot of organizations transferring or trying to transfer risk to their contractors. And you see big companies trying to transfer risk to smaller maintenance service companies, and that usually leads to big increases in cost. So that's another thing to watch out for. But typically, I would say, especially have significant an outsourcing component, you should be able to achieve at least a 5% cost reduction here through better writing of contracts and also carefully thinking about what you do contract out and what you don't contract out. And so that is basically the four things you need to focus on. If you do these four things well, that will significantly reduce your maintenance cost, and it will do so in a sustainable manner. Right? And when you work through that framework, you will find that what you maybe initially considered to be impossible actually becomes possible. It will take a bit of time. This is not something you can do in a couple of weeks, but it becomes very, very possible. And there is no real secret here. The key thing is to understand that your maintenance costs are typically inflated because of the large amount of waste in your maintenance processes through activities you're doing that don't need doing, through repeat failures that you should be eliminating, and through a lack of productivity that you can tackle. And if you do that, you will be bringing down your maintenance costs, and they're going to stay down. Right? And that's the big difference between just simply cutting costs and actually tackling these processes. Now, in my last role in the corporate world, I was the maintenance reliability manager for a large-scale LNG plant. The annual maintenance budget varied between $60 to $90 million. And part of that role, I developed a cost reduction program, which was based on these very principles of improving maintenance productivity, eliminating non-value adding PMs, just getting rid of the task we don't need to do, eliminating bad actors, so eliminating those repeat failures, and negotiating better rates and better contracts and getting more value out of our contracts. And no matter whether you have a big budget or a small budget, these four principles remain the same. And it's all going back to the fact that you need to eliminate waste. You need to make sure you're doing the right things, and then you need to do them well. And above all, as I mentioned earlier, you need to remember that maintenance costs are a consequence. They're a consequence of the maintenance we do. So those are the tasks we do, the work we do, and how well we do that work, how efficient we do that work. When I work with clients, I typically recommend we execute, if there's a real focus on reducing costs, we execute that focus in these four steps in the sequence you see here, starting with improving productivity, because once that's done, it gives you much more capacity to get other improvements done. Typically, a lot of clients we work with have a relatively reactive maintenance culture, and improving productivity, improving planning and scheduling stabilizes the working environment. And in a more stable working environment with less stress, less firefighting, you find that the teams have more time, more headspace, are more motivated to actually get after some of the other improvements. Now, I don't really have time to go through those four steps in a great amount of detail, but we'll touch on each of them quickly to give you a bit more insight into what is involved, what needs to be done. So as I said, the typical wrench time is around 20 to 30%. And with proper planning and scheduling, you can increase that to about 45%. And that's an increase in productivity without hiring anyone of about 35%. And the great thing is, when it comes to improving your productivity through better planning and scheduling, there is a very limited investment requirement. So as a project, it has a fantastic return on investment, which makes it relatively easy to sell to corporate leadership. We actually have a tool that people can use. It's called the wrench time calculator, and it lets you estimate how much value you can gain from implementing maintenance planning and scheduling. The thing is, you want to use a proven framework for implementation, because what we find is that it's the implementation, the rollout of the work management framework and the processes and training people where most companies go wrong. And so the result is that very often the improvements are rolled out, but they're not sustained. Which is why I always like to say that implementing maintenance planning and scheduling is a change management project. So it combines three key elements, understanding planning and scheduling and how to do that well, understanding change management, because ultimately you have to influence how a lot of people work, right? Technicians, planners, schedulers, operators, supervisors, superintendents, a lot of people have to understand how the new work management process works. And ultimately, it's also it requires a bit of project management, because you don't want to be doing this forever. You want to basically get on with it and have it delivered in 6 to 12 months. So you do also have to have some good project management skills to deliver this within the time frame. So those are the kind of key things you want to focus on. It is very, very doable. And like I said, typically 6 to 12 months is a good time frame for a large industrial asset to do this. Once you've done that, you really want to start looking at those non-value adding preventive maintenance tasks. And as I said earlier, experience literature shows that 40 to 60% of the PMs add little value. John Mowbray in his book RCM2 wrote that back in 1997 as one of the first, but it's seen again and again and again by a lot of people who do this kind of work in a lot of companies. Now, the way to do this, you can make it very complicated. I don't like complicated things. I like things simple. So what I typically recommend to clients is you do some simple analysis of your PM program, and you generate some very basic Pareto charts that show you, which systems cost you or which assets cost you the most money on an annual basis in terms of your PM costs, so your preventive maintenance costs, in terms of your corrective maintenance costs, in terms of your total spend, in terms of failure, in terms of downtime. And when you do that, you probably have 5 or 10 different types of Pareto charts, and you look at that, you very quickly see which are your problem equipment. And chances are your team already knows that, right? It's still good to do the exercise and get the data because it helps you justify the systems you pick in the sequence. Now, once you have those Pareto charts, it's a matter of basically getting your stakeholders together, agree on the priorities, and then start tackling those systems one at a time. And then within that, you need to look at the failure modes. This is something where things typically go wrong. You really need to analyze, okay, how does this equipment fail? Is that failure mode credible? Have we experienced it? What's the consequence, and what do we need to mitigate the potential failure, right? There's different methodologies you can use. You can use failure modes and effects analysis. You can do RCM. You can do PMO. It depends a little bit on the maturity of your PM program, the complexity of the system you're dealing with. But ultimately, it all comes down to just analyzing your failure modes. Now, what is really, really important, there's actually two things that are really, really important where, again, these things often go wrong. We often see people do this and come up with preventive maintenance tasks that still are not aligned with basic reliability practices. So people using time-based replacements for failure modes that actually have a random failure pattern. That happens because a lot of maintenance staff and a lot of engineers haven't actually learned some of these reliability principles along the way, and so decisions aren't always made the best. So it is important to make sure that the people who are working on this understand those reliability principles, can apply them, and can really build PM programs that are efficient and effective. And then the other thing is, it's really important that you implement this on a system-by-system basis. I see a lot of organizations that kick off an improvement of the PM program, and they go and start every single preventive maintenance task they have in their system. They'll spend 6-12 months analyzing it all. Very often what happens is they burn through a lot of time, a lot of man-hour, a lot of money, do all their analysis work. By then, they're starting to lose steam. Now they've basically got all these new tasks. They need to write new work instructions, which is another heap of work. And before you know it, you're 12, 18, 24 months down the line, and nothing has really improved. You spend a lot of money, and often it happens that the project at that point falls apart. Leadership support disappears. A lot of money has been spent, but no tangible benefit. So what you want to do, and it sounds very simple, and it is very simple, is just do this on a system-by-system basis. So you think that your export pumps or your compressors or whatever machine, production line one is the critical issue, tackle that system, that piece of equipment, whatever it is, tackle that system, analyze the failure modes, identify the new tasks you need to do, write the work instructions that need to be done, set it up in your CMS, train your people in it, and go live. And then do your next system. So you don't analyze everything and then implement everything. You do it system by system, almost like on a sprint basis, right? That means that once you've done the first one, you implement it in your CMS, and the results will start showing from that point onwards, right? So you're building essentially a staircase of small incremental improvements on top of each other, rather than trying to do it as one big program. So once you've done that, your third step is to tackle your bad actors. Now, as I said earlier, you typically have a few pieces of equipment in your plant that are responsible for the majority of your breakdowns, the majority of your corrective maintenance spend, the majority of your workload, et cetera, et cetera. And so it's a matter of delving into your corrective maintenance history in your CMS. And again, develop a set of Pareto charts that show the worst performing equipment in terms of corrective maintenance cost, corrective maintenance effort, failure frequency, et cetera. And this aligns quite a lot with the Pareto chart you do in step 2, but there's a slight differentiation in the sense that here you're not looking at your PMs, you're really looking at downtime and corrective maintenance cost. And then what you usually find is, like I said earlier, you have a handful of equipment where you really, that you really need to fix, that are causing the bulk of your pain. And so you then get key stakeholders together like operations and engineering, and you prioritize those 3 or 4 or 10 bad actors, and you start to do proper, sound root cause analysis of what is happening there, right? And then you need to make sure that you don't stay at a superficial cause level, because this is what happens a lot. You see a lot of organizations, you say use 5Y, or even if they use more advanced processes, very often they stay at a superficial level rather than going to the systemic level. So for example, they might say, okay, the technician installed this incorrectly. That's all right. So we blame the technician, or the operator made an error operating the equipment. But why did the technician install it incorrectly? Was the technician called out at 2 a.m. in the morning for the third time that week and just too tired to do it? Was the technician ever trained on how to do this? Is the equipment really poorly accessible, so it's a very hard job to do, etc., etc., right? So you want to get down to the underlying systemic issues. Those are the issues you need to eliminate and then resolve. It's actually not too difficult. People make out root cause analysis and defect elimination as very complicated. There's heaps of different methodologies out there, but ultimately it all comes down to finding the systemic issues, making sure you have data and you make decisions based on data and evidence. That's the other thing. You see a lot of people write root cause analysis reports and make conclusions when there's actually no evidence to underpin that. Now, sometimes you do not have evidence. That happens sometimes, that you have a bunch of causes. Some of them are possible causes because you just don't have the evidence to support them, and you may actually have to go out on a limb and implement certain remedies for it. But in principle, you want to make sure you have evidence to underpin your causes so that you can tackle them properly. And then the fourth element, when it comes to negotiating better rates and contracts, the most important thing is to get really clear on what you truly need. Right? Because as I said earlier, you see a lot of organizations who specify things in their contracts that they don't necessarily need, but that do drive up prices. And very often there's actually not a good understanding of how that works on the part of the company that is writing the contract. So, what you want to be doing is reviewing your specifications and requirements internally, but then also sitting together with your suppliers and your service providers and contractors to really understand, okay, well, which of these requirements is actually driving up a lot of your costs, right? And then see what you can eliminate, see what kind of risk you're willing to take, see what kind of win-wins you can create. And usually you find that there's a lot of opportunity in that space. Now, as I said earlier, it's important that you incentivize your contracts properly so that you drive ownership and you eliminate waste, right? And the important thing there is to make sure that the incentivization aligns with your corporate objectives. I've seen in the offshore industry a couple of decades ago where contracts were incentivized on one particular metric, executing PMs on time, right? So all the PMs were getting done on time. But guess what happened when one of the plants tripped and production stopped? The contract labor basically said, well, we're going to continue doing our PMs because that's what matters for us the most, right? So it was a really hard conversation for getting that contract labor taken off the PM jobs that were due that day to go and fix certain urgent correctives because they were not incentivized by that. It sounds very simplistic, and it is, but very often these things are underestimated. So it's really important that you align your contractor incentives with your own high-level objectives. And usually that means actually that it doesn't become very crystal clear. But at least there is then alignment. Really important part is you actually just need to engage with your service providers and contractors and really kind of get to understand their business, understand what drives their costs, and share with them that it's important to reduce costs. Chances are you'll be surprised. Good suppliers understand the importance of a long-term partnership, understand the importance of having to reduce costs systematically, and they'll be willing to do what they can, right? And then if you do have some suppliers that don't really want to have the conversation, are not willing to get involved, well, then that might also be an important signal to you to think about what to do with those service providers. And ultimately, this is where, it's really important as a maintenance community, we work well with the procurement and contracts team to do this, because for most maintenance and reliability practitioners, this is not our core area of expertise, and this is where it's so important to partner with procurement and contract specialists who can show best practice and lead those kind of conversations and those processes. But typically, there is also a significant opportunity here. So again, that's why you want to get after it. And so with what I've discussed, those 4 steps, those are key to reducing your maintenance costs sustainably. Now, as I said earlier, this is going to take a bit of time. This is not something you can do instantly. Now, if you are in a bit of a pickle and you need to get your costs down very quick, you may want to try and change the sequence. That's usually not the best way to do it. It sometimes can work. What I typically recommend, if you're really in a hurry to reduce your costs, what you try and do is you work these themes in parallel rather than sequentially. But trying to improve productivity when you're doing the wrong work. So, step 1 is eliminating work that doesn't need doing. That is really important. There's no point in being very efficient in doing work you don't actually need to do, right? So that's actually why that is there. But step 1, eliminating those non-value adding PMs, that is typically something you can make a big dent in your workload in the space of 1 or 2 months. You could probably take 10, 15, 20% of your workload out. Once you've done that, then you can probably think about, negotiating and engaging with your biggest contractors to see if you can negotiate rates and if you can work on your standards, your specification, your ways of working, etc. Once that is done, you can probably start eliminating your bad actors. And the last thing you do if you're in a hurry is to work on productivity. And the reason you put that last is it takes a while. In a large industrial asset, it typically takes 6, 12, maybe 18 months to really get a sustainable improvement in productivity. It doesn't just happen overnight. The best performing assets where you have a lot of leadership support, a very strong case for change, and very motivated personnel, you might break the back of it in 6 months, but even then, it's going to take 6 months. So that's it. In all cases, whether you're in a rush or not in a rush, you still need to work through those 4 elements. But one thing I just wanted to mention, I kind of leave with you because it struck me in the past when I look back at what we achieved in some of the assets. There's a quote from Bill Gates, who basically, I don't know when he exactly said it, but he said that, as humans, we tend to overestimate what we can do in 1 year. We've all been there, but we also underestimate what we can do in 10. Now, I'm not saying this will going to take you 10 years, but what I'm trying to say is it's pretty dramatic what you can achieve if you focus on those 4 basic elements. If you get those really working, you'll be amazed by how far you can bring your costs down and still maintain, in fact, even improve your availability and your reliability and your overall maintenance performance. So keep that in mind. Be careful with what you promise for the next year, but don't be shy with what you can achieve in the next 2 or 3. So that's all I had to say for today. So that gives us plenty of time for questions. If you like what I shared today, if you're interested to know more about how we do this, how we help clients implement these improvements, and whether this could be a fit for you or your plant, your organization, feel free to reach out. It's pretty easy. We can book a call. We can just have a chat. You can go to reliabilityacademy.com/call. My diary comes up. You can book a call, or you can reach out to me on LinkedIn. Just look me up on LinkedIn, Eric Pierre. You should be able to find me very easily. All right. I will stop sharing my slides there and we go to questions. Oh, excuse me. All right. Let's see. I'll stop sharing. No questions in the Q&A. That is easy. Let's see. Any questions in the
Yeah,
chat?
no questions. Do we have any questions, guys? If you have any questions, please use this Q&A box. Eric is here to answer your questions. Eric, can we wait for 2 minutes if anybody would like to ask
Absolutely.
questions?
No
Yeah,
problem. No
yeah.
problem. I know you mentioned that the session is recorded and made available on YouTube. I'm also more than happy to share the slides as a PDF. So if you want anybody who attends or anybody who registered wasn't able to attend, happy to share the slides if that's helpful.
Oh, that is great. Please share your presentation with me through email, and I will send this to all of the registrants.
Yeah,
So
no problem.
maybe people who are not able to participate today, who just registered but not able to, get time to join the webinar, we can share the presentation with them so that they have idea what is all about.
Mhm.
All right, I think we do not have any questions now.
No problem.
All right, so thank you so much, Eric, for this amazing presentation. I'm sure our all the attendees would have learned a lot from this presentation. And thank you so much, you all, for joining this webinar today. And I hope you found this shared information useful and insightful. Remember to apply this knowledge gained in your work and share it with others as well. This webinar recording will be shared with you and uploaded to our ASCI YouTube channel in a few days. Also, as Eric mentioned, he will be sharing the presentation. So I'll be sharing this presentation with you through email. Don't forget to check out the website for more resources and upcoming events. Thank you so much for today and have a great day. Thank you so much, Eric.
Thank you. Take care.
Thank you. Have a good day. Bye.